Hey darts fans, it's Timo Newman here, the transporter. Welcome to this voyage of the good ship Undoubted Waters, the secrets of the dartboard. This is the second episode in this series. I thought there might be 5 videos, but there may even be more, because as I'm making these, I'm actually thinking of new stuff all the time. It's very exciting. But anyway, one of the things we're going to learn today and tomorrow is that the double is underrated for scoring. And look at that, the good old Jose de Souza, and then Luke Littler, a good 120 with 3 double 20s, eh? So what I'm going to do is give a brief recap of yesterday's video, which was a bit on the long side, and then get right into what I promised of these nuggets, these beautiful little facts that come from measuring the geometry of the dartboard. Okay, so let me just get my whiteboard. Take 3. I'll just turn that light off there. So I'm having a hard time with this video. My first take was way too long, because I tried to give technical details and do 2 nuggets. And then my second attempt just now, I had a total brain freeze and just froze up. So trying again. So welcome back. I can't give you technical details in this video on how to calculate these things because it takes too long. But this is real science. We don't cover stuff up here. So if folks would like to have a short video of me going through how to work these things out on the whiteboard, I'm really happy to do that, because I want you to know that this thing is all real. Okay, but it just takes a long time, and for most viewers, I think they just want to know the results. So I'm not going to do the technical details. I did describe how to do it in yesterday's video, talking about the diameters of the circles and how to calculate the area of a ring as the difference between 2 circles, and so on and so forth. Okay, but I can go through that in detail if folks would like. And you saw all the measurements to all the data we need for that in yesterday's video. So all the information is available to you. I'm just not going to do it explicitly. Now, we're just going to do one nugget today. And this nugget is going to be about the double and the treble, their relative sizes. Okay, but let me first of all just remind you what our terminology is, because we have to be very precise with our language. Okay, so we're going to call the sort of the number, you know, whatever number of the dartboard it is you like, but that kind of pie slice, not including the bull ring, we're calling that the whole segment. And then we're using double and treble, and then big single and small single is going to be our way of describing those 4 different regions within one segment. Okay, now that we've got that language established, let me just erase those, because what I want to write in instead are the results when you go through those calculations using those measurements. What are the relative sizes of these regions? And I'm going to write them compared to the whole segment. So the whole segment is 100%, and what are the percentages of these 4 regions? Well, what you find is that the big single is 49.1%. I'm just going to approximate it as 49%. And that's already an interesting thing, that the big single is almost exactly 1/2 of the whole segment. So it's the big daddy of the segment, if you like. And what's the small single is 32%. To be precise, it's 32.1%. And I misquoted that. That's 49.0%. So we even know the first decimal point of these: 49.0, 32.1. Together, the whole single of a segment is 81% of the segment. That's quite a good thing to know. So over 4/5 of the segment is a single. But the really cool stuff is this double and treble. So what's the double? The double is 12%. to be exact, 11.8%, and we're approximating it to 12%, and the treble is 7%, okay, or exactly 7.1%. So these numbers are like a gold mine. Just those 4 numbers you can do so much with, and we're going to do the first nugget right now comparing the double to the treble, but there's a lot more that you can do, and we'll see another nugget from these numbers tomorrow and another nugget the day after. Okay, just from those numbers, there's so much you can get from them. Again, we're doing science. What do scientists, what do scientists do? That's a loaded question. In good science, one thing you always do as you're doing your project is you check, because mistakes are fatal. All these numbers should add up to 100%. Let's make sure that's true. So you've got 81% for the single, plus 7 is 88, plus 12 is 100. That's perfect. Okay. Now, I want to get right to it now with the double and the treble, because this is probably my favorite result of all the nuggets in this whole series. It's got so much in it. And it was what prompted me to do this study in the first place. I was just curious, what is the ratio of the size of a double to the size of a treble? And we can work it out. So the size of a double compared to the size of a treble is roughly 12% over 7%. Let me use the more precise numbers, 11.8% over 7.1%. And this, I've done science for decades, and what you sometimes find is if you're just kind of going along, doing it honestly and carefully, sometimes nature just is kind to you and gives you beautiful things. This ratio is a beautiful thing because it's exactly to 2 decimal places 1.66. That's really remarkable. So you use your ruler, you measure your dartboard, you go through the motions, you work out the ratio of the size of a double to the size of a treble. What do you get? 1.66. Why is that cool? That's cool because that is a simple fraction. That is 5/3. And that is our first nugget. And this is a number that every dart player in the entire world, or even galaxy, if darts is played elsewhere on Alpha Centauri or somewhere, maybe they don't know this. We might need to send a message. But 5/3, crucial number to know. The size of a double compared to the size of a treble is 5/3. Right? It's more than half as big, but it's not quite twice as big. It's in between. It's 5/3 the size of a treble. So if you're going for trebles, for every 3 trebles you get, you should be getting five doubles. It's 5/3 sort of easier to hit, if you like. Okay. So why am I so interested in this number? I think for me the main thing it tells me is that that's actually, if the double is 66% bigger than a treble, that's a lot easier to hit. That's a lot bigger area. And when I go for doubles now, I remind myself, this is a big target. This is 66% bigger than a treble. And that makes me feel confident when I go for doubles. And I have a higher chance of hitting them because I'm more relaxed. So that's one thing. But what we can use this number for, very straightforwardly now, is to ask a question. How do elite players do in hitting doubles? And what we're going to find is this number gives us a measurement of psychology and stress in the elite game. So let me just make a little bit of space for myself here. And let's just talk about elite darts. So your Gerwin Prices, you're the 2 Lukes, the Michael Van Gerwens, whoever your favorite players are. Let's look at elite darts. Now, one thing that the PDC website does every maybe month, there's I think the gentleman's name is Christoph can't remember his surname, but he's a statistician. He writes a really good column every month where he does the form guide, and he lists the 10 best players of that recent period, what their per visit average is, and also he'll list their doubles success rate as well. And roughly speaking, the per leg average for these elite players is roughly 100, high 90s or 100, and the doubles percentage success is roughly 40%. Those are very typical numbers for those top 10 players. This is at the elite level of the sport. Now, we can actually use these two numbers to compare them to this 5/3. How do we do that? Well, here's how we do it. This 100 average per, that's not per leg, that's per visit, sorry. Per visit, I'm glad I caught that. Per visit. Per leg average would be me playing them. I'd probably get 100 points before they finished the leg. The per visit average. If you've got a per visit average of 100, let's put aside the fact that you've got the messy checkout at the end, which kind of lowers your average. But roughly speaking, 100 means that you're getting typically a treble 20 and two 20s, because they're nearly always aiming at the 20 segment before they check out, okay? So if you've got an average of 100, you're roughly getting a treble 20 and two singles. That means that this number means that your treble percentage, your success rate at getting trebles is roughly 1 in 3. Because of those 3 darts, you get a treble and 2 singles on average, and that gives you that 100 per visit average. Okay. Now, if there was no psychology in darts, if we were just robots playing this game, then the probability of us hitting a target is just the size of the target. And we've just established that the double is exactly 1.66 or 5/3 bigger than the treble. So if you're hitting trebles with a success rate of 1/3, and I understand that that's the treble 20, which is a target they go for a lot, but that treble they're hitting with a rate of 1/3, what should then be their success rate with doubles? It should be 1/3 times this factor of 5/3. So they should be getting doubles, should be, robot would be getting doubles with the treble success rate times this factor of 5/3, okay? And that's 5/9, and I've got my calculator here. What is 5/9 as a decimal? This poor calculator, it's so old. This one I used at school, it's just clinging on. 5 divided by 9, right, 0.56. So this is 56%. This difference between 40% and 56% is a measure of psychology and stress in elite players. They're underperforming by almost 50%. So if they were doing 50% better than 40, so you know, a doubles rate of 0.4, 50% better than that would be 0.6, which is roughly this. So they're basically underperforming massively. And it's much worse than that, to be honest, because this per visit average of 100 includes the checkout. So it's not really a good measure of their trebles, right? So if you actually looked at say the 9 dart, first 9 dart per visit average, it would be more like 110 or 120, which means that their treble success rate is actually more like a half, actually. It's more like a half, and you multiply a half by 5/3, you start to get this number creeping up to 80%, which is incredible. So all things being equal, no psychology, given the treble hitting rate of professional elite players, they should be hitting doubles at 60, 70, even 80% as an average. Not at their best, but as an average. But their average is 40%. So you can see the incredible effect of psychology on even the elite players, that when they go to get that double, because it's the last shot of the leg, the stress comes in, and they basically their skill evaporates, and they perform 50 or 60% of their best. And if they were able to quell somehow, I don't know how, if they were able to quell that inner conflict that I talked about yesterday between the unconscious and the fake reality of the visual conscious, and just use the facts that, hey, the double's a really big target, it's 5/3 bigger than a treble, I'm really good at hitting trebles, I'm going to be even better at hitting doubles, then they would be doing so much better, and they would win pretty much lots more games because they'd be finishing beautifully. Okay, so I love the fact that you can just go to the dartboard with a ruler and calculate all this stuff and start to get insights into elite sport in darts and the underperformance of the elite players. I mean, they're brilliant, but they're underperforming in the doubles massively because of mainly, I think, psychology. You may think of other reasons why there's this huge gap in performance on the doubles beyond nerves. Maybe it's to do with the fact they have to get different doubles, or it's throwing at different parts of the board, and we can discuss that in the comments section. So let me leave it there. Even this first nugget has taken quite a long video, but I really wanted you to see how much you get from very, very little. And the best science is always where you get a lot out for putting a little in. Bad science is where you put a lot in and get very little out, and there's a lot of bad science around, folks, and it's really expensive. But that's a topic for a different channel, not this darts channel. So with that, let me grab my trusty arrows here. Thank you ever so much, everyone, for your support. I really welcome your feedback. If there are things you'd like me to improve or change about the videos, drop me a line and I'll see what I can do. Until then, 3 darts at the oche, make them count. All the best.